All right, shall we start our session or is anyone else also joining? All right, so let's start our session. The first question is on your screen. Six resistors, each of resistance R, are connected as shown in this figure. What is the effective resistance between points A and B? Yes, Kritika, right answer. Did anyone else also got the answer? Yes, Nishya, right answer. All right, let's see the solution of this question. Whenever a symmetrical structure appears like this, then what we do, we can just remove the circuit and make the branches like this. All right. So here we can see the two resistors over here get in series. So this becomes 2R and this becomes 2R. And then if you take all these four in parallel connection, then you will get the answer as R by 3. All right, let's move on to the next one. In the circuit shown in the figure, the heat produced in the 5 ohms resistor due to current flowing in it is 10 calories per second. The heat produced in the 4 ohm resistor is. Yes, this is the right answer. Shall I proceed with the solution or do we want more time? Alright, take your time. Alright, I think we should proceed with the solution now. The heat produced in the 5 ohms resistor due to a current, suppose it is I, then the heat is I square R. So I square into 5 is given as 10. So that gives me I square equals to 2. Now this complete setup is having 10 ohms. So this is double of that in the lower branch. So half of the current will flow in this one because the resistance is inversely proportional to current. So I by 2 will flow in this branch. So for 4 ohms, I have I by 2 square into 4, that is I square by 4 into 4, and I have I square equals to 2, so this gives me answer as 2 calories per second. So B will be my right answer. Alright, clear to everyone? Alright. This figure shows currents in a part of an electrical circuit. The current I is, this I you have to find, and the different current in different branches is given. This 1.3 ampere is for this branch. Yes, Kritika, right answer. Yes, it's the right answer. Alright, this is a very easy question. So this 2 and 2 are coming at this junction. So this will be 4. 1 ampere has left the junction, so this will remain as 3, and 1.3 has left from the junction, so the remaining will be 1.7. That is the C option. Alright, let's proceed to the next one. The meter bridge circuit shown in this figure is balanced when jockey J divides wire AB in two parts, AJ and BJ, in the ratio 1:2. Then the unknown resistance Q has value. Yes, Kritika, right answer. Yes, Nishya, right answer. The ratio of the wires is 1:2. So as the meter bridge works on the principle of Wheatstone bridge, so the ratios will be equal. So Q will be double of 1.5, that is 3. So 3 will be my right answer, option B. Alright, let's move on to the next one. In this in the steady state in the circuit shown, then there are 4 options regarding different properties of the circuit. See which one looks correct. Sorry guys, there was some network issue. Is my screen visible? Yes, Nishya, right answer. Shall we proceed with the solution or do you need more time? Alright. The question is mentioning about steady state conditions. So in steady state, the current is zero. And if the current is zero, then no current is flowing through the resistor. So therefore, volt potential difference across the resistor will be zero. So B cannot be the answer. Now the plates will be obviously they will have some charges because in the steady state they are completely fully charged. So D can also not be the answer. Now we have to find potential differences across both of the capacitors. So there is an easy method. This 14 volts is divided between both of them, and we know that C is inversely proportional to V. So by that we can see that 10 microfarads will be having 4 and 4 microfarads will be having 10. So the A is the right answer. Or if you want to go with the general method, then you can also say that suppose Q charge appears on the plates, then what do we have? V C, Q equals to CV, so V equal to Q by C. So Q by C for both of them, that is Q by 4 plus Q by 10 will be equal to 14. So from here you will get 14Q upon 140 equals to 14. So from here you will get Q equals to 140 coulombs. And when you distribute the charges and then calculate the potential difference, from there also you'll get the answer as A. Alright, let's move on to the next one. In the given circuit diagram, find the value of current in resistance R. This is the R. Shall I proceed with the solution? Alright. See, whenever a circuit like this appears where there are multiple batteries joined together, then if there is no other device in between, then you can simply add up their values by the concept that if this is 12 volts, so it is having a potential difference of 12. Suppose this is X volts over here, then this point over here will be having a potential of X plus 12. And similarly, this is 6 volts. And if this point is at X plus 12, so this will be at X plus 18. So now we have this resistance R, which is having a potential difference of how much? This is having potential difference of 18 volts between this point and this point. So 18 volts with R equals to 9. So current, that is V equals to IR. So from that I can get I equals to 2 amperes. So as this is a parallel connection, this whole branch and this whole branch is just like a parallel connection for both of them. So this portion will not be considered at all. This has no interference with the circuit in the above branch. All right. So A will be the answer. Clear to everyone? Doubt है किसी को? All right. The current in branch CD of given circuit is. No critical wrong answer. I hope you are using KVL to solve this. I'm so sorry, guys, for the network issue. Am I audible? Yes, A is the right answer. All right, let's see the solution. Suppose a current I is traveling in this branch, and from here, suppose I1 gets into this branch, and the remaining flows from here. Suppose I minus I1. So I first consider the loop BACD, this one. So from starting with B, I have plus 12, then minus 2I, then the decreasing voltage, that is minus 4, and towards the direction of current, so minus 4I1, that is equal to 0. Now in the second loop, that is DCEF, I have against the current, so plus 4I1 towards positive of the battery, so plus 4, and then with the direction of current, so minus 3I minus I1 and plus 8 equals to 0. So this simplifies to the first one becomes 8 minus 2I minus 4I1 equals to 0, and the second one simplified becomes 4I1 plus 3I1, that is 7I1 plus 7I1. This is 4 CD, that is I1. Am I audible? Alright. So I want to find I1. So can I eliminate I from these equations? If I multiply this by 3, I'll get 24 minus 6I minus 12I1 equals to 0. And if I multiply this by 2, I'll get 24 minus 6I plus 14I1 equals to 0. And if I subtract both of these equations, I'll get minus 26 I1 equals to 0. That means I1 equals to 0. So that means A is the answer and no current is flowing in this branch. Is that clear? Clear to everyone? Is the is the question clear to everyone? All right. Try this question. We want to find the ratio of current I1 by I2. Did anyone get the answer? Shall we proceed with the solution? All right. See, first we can very simply draw the circuit in simpler manner. That is, like, we know these are in series, so this will become 4, and these are in parallel, so this will become 4, and then this 4, 2, and 2, they will come in series, so this complete branch will become 8, and then this 8 and 8 are in parallel, so it will become 4, and then this 4 and 4 will become again 8. So I can see that if I make this as 4, this is 8, this is 16, and over here I can make a single resistor of 8. Alright, and I have this as I1. So see guys, this is a potential directly applied at 8, this 16 volts. So I can say that V equals to IR gives me current over here as 2 amperes. And just like we discussed in the previous question, suppose I take this potential as X. So by this 8 volts, this point will become X plus 8. And similarly, at this point, by this 16 volts will become X plus 16. So what is the potential difference available for this 4 ohms? It will be 8 volts. All right. So by Ohm's law again, I have current flowing from higher potential to lower potential, and 8 equals to 4 into I. That will give me I as 2 amperes. So you can see from this junction a 2 ampere is going here and 2 ampere is going in the other direction. So I can say that I1 will be 4 amperes. Alright, so my I1 has come as 4 amperes, and 2 ampere is going in the left branch. That means over here I'm having 2 amperes. Now, as we calculated earlier, this 8 ohms is available for this complete branch, and 8 ohms is available in the parallel branch as well. So this 2 amperes will get equally divided in both of these partitions. So 1 ampere will go downwards and 1 ampere will be carried on in the last branch. Now this 1 ampere is coming here, and now it is going to get divided into this and this branch. So will it get divided equally? Yes, because both of the resistors are equal in magnitude. So this one has become 0 0.5 and 0 0.5. So my I2 becomes 0 0.5 amperes. So my I1 has come 4 amperes, and I2 has come as 0 0.5 amperes. So my ratio I1 by I2 will be 4 upon 0 0.5, that is equal to 8. So B is my right answer. Alright, आ गया सबको समझ में? Alright, let's just take one more question for today. An easy question. In the circuit shown, a meter bridge is in its balanced state. That means no current is flowing through this galvanometer. The meter bridge wire has a resistance of 0.1 ohms per centimeter, the value of unknown resistance X, and the current drawn from the battery is. Yes, Kritika, right answer. Yes, Nishya, right answer. Alright, let's see the solution. The value of unknown resistance X is very simple to find as it will be in the ratio. So this will be equal to 4 ohms. Now the current drawn from the battery, for that we need to find the total resistance, the equivalent resistance. So in the circuit we have this as 10 ohms and we have the wire. Now this wire is 0.1 ohms per centimeter and the total length is given as 40 plus 60, that is 100 centimeters. So the total resistance will be 0.1 into 100, that is 10, and 10 and 10 in parallel will become 5 ohms, and 5 ohms with 5 volts of battery, that will give me I equals to 1 ampere. Alright, so 4 ohms and 1 ampere, so C will be my right answer. Alright, clear to everyone? Alright guys, that's all for today. Thank you for joining. Bye bye, good night.